All right, this is section 2.1. It's the beginning of the chain rule, which is another huge rule along with the product and quotient rule for derivatives. The book will define it as a composite function, so the derivative of a composite function. And what you do is you take the derivative of the large function and then you take the derivative of what I call what's inside of it. In general, the general power rule says that you will bring your exponent out in front, rewrite it, lower the exponent by 1, and then take the derivative of what's inside. It will be easier for us to just go ahead and do some examples. So the first example I'm going to do is on page 137, number 2. When we go ahead and take this derivative, before we take the derivative, we want to rewrite this because we do not want to do a quotient rule. It's much easier to rewrite it and then take the derivative of it. If you notice, what we have is much more than an x. If I would have just had an x, so this is a side problem here, if this would have just been an x, my derivative would have just been negative 1/2 x to the negative 3/2. Because it's not just an x, this is actually using the chain rule. The derivative of this function, we're going to treat it just like it is a big X. We're going to pretend that the highlighted section is just a big X. We're going to bring out the 1/2. We're going to do what I say, rewrite the inside. We're going to lower it by 1, so negative 1/2 minus 1 is negative 3/2. And then the last thing we're going to do is take the derivative of what's inside. When I'm saying that, I'm taking the derivative of what's inside the parentheses. So the derivative of what's inside of the parentheses, since it's not just an x like it was in the first side example I did here, I need to make sure that I am finishing this. In this case, it does just happen to be a 1. But in many cases that follow, that will not be the situation. So to finish this up, I'll just simplify it by writing negative 1 over 2, the square root of x plus 1 cubed. And I will stop at that point. I am jumping slides, and I'm going to jump to number 8 of page 137. In the next video, I will cover the trig functions. In this one, if I go ahead and just jump right into taking the derivative, we're going to pretend that this is a big X. And if it was a big X, we would just bring this out in front. So maybe I should write that off to the side. What if I had just a big X there? It would be 2, like this has out in front, x to the 5th. And I would bring this out in front and I'd write 10 x to the 4th. And that would simply be my derivative. I'm still going to do that whole step. 5 times 2 is 10. This time, though, I don't just have an x, so I have to rewrite what's on the inside and lower it by 1. There's my 10x to the 4th. But since this isn't just simply an x, I have to take the derivative of what's inside of the parentheses. What is the derivative of what's inside the parentheses? Well, the derivative of 6 is 0, and the derivative of negative x squared is negative 2x. I'm not going to leave my answer in this form, however you could. I'm going to go ahead and simplify it. I'm going to go ahead and multiply the 10 times the negative 2x, which gives me a negative 20x. And then I'll just go ahead and leave this as 6 minus x squared to the 4th power. Okay, this is the second video of 2.4 day 1. And I'm going to go ahead and introduce the trig rules to you and how chain rule and general power rule apply to the trigs functions. So these are all the trig functions that you guys were to memorize, and you should have memorized. The first one, and what I want to do is I want to explain to you this notation. This d over dx, remember, stands for the derivative with respect to x. We don't have x's in this problem. That's why at the end here, they say that the derivative with respect to x is the sine of u and then a u prime, meaning they're taking the derivative of u. So let me explain that just using a small example. If I ask you to find the derivative of sine of x squared, this isn't just an x anymore. So we don't know the derivative of sine x is cosine x because it's not just an x. What we want to say is that the derivative is cosine of whatever the u was. In this case, it's the x squared times the derivative of that u. The derivative of x squared is the 2x. So this is in essence, the composite function. They've replaced x with x squared. So now you kind of have the general idea of what the u prime and u stand for. We'll do a couple other examples. The first one I'll do is number 4 on page 137. I am just going to start taking this derivative. So I'm just going to write y prime. Anytime we have a constant, we've talked about this many times, we bring down the 3. So we just bring down the number that's out in front. The derivative of tangent is secant squared. Now, this wasn't just a plain old x, and that's okay. This is my u. I'm going to write the u as it is. So because this wasn't just a plain old x, I have to remember to take the derivative of this highlighted part. The derivative of what's inside, then, is 2 pi x. I would rewrite this. I would put together my 3 and my 2 pi x. That would give me a 6 pi x times secant squared pi x squared. That's as far as I would simplify this problem. Moving on to another example. We'll go back to some that don't have the trig functions in them. This one, I'm going to go ahead and rewrite negative 3. And this would be 2 minus 9x to the 1/4 power. Much easier to take the derivative once we have rewritten it. So the derivative of y ends up being, bring this out in front, you're going to hear me say this many times, negative 3/4. Rewrite it, 2 minus 9x, lower it by 1. So 1/4 minus 1 is negative 3/4. Now the last step is to take the derivative of what's inside. The derivative of the 2 is 0, and the derivative of the negative 9x is negative 9. That is the chain rule in itself. So I brought the number out front, rewrote it, lowered by 1, take the derivative of what's inside. Last thing I'm going to do is simplify this very quickly. I'm actually going to end up getting, when I multiply the 3/4 and the 9 together, I'm going to get a positive 27/4. And then I have the 4th root of 2 minus 9x cubed on the bottom. Just start off and rewrite this as we've been doing. Much easier again to take that derivative when we have rewritten the problem so it's not in a fraction form. So now that it's rewritten, I'm ready to take the derivative. The derivative then, I'm going to pretend this is my big X. I'm going to bring this out in front. I'm going to rewrite what's on the inside of the parentheses, lower it by 1, and take the derivative of what's inside. So just like the power rule or the product rule and the quotient rule, I have my little sayings as I'm going through the derivative just so that I make sure that I do it properly. So I brought that out in front, rewrote it, lowered it by 1, took the derivative of what's inside the parentheses. The last thing I'm going to do is just simplify this. So when I simplify it, I'll go ahead and say this is a negative, I'm getting that from right there, I'm going to put my 2t plus 3 out front. And then I'm going to go ahead and put this on the bottom of the fraction, this last part, because it is to the negative second power. So I have t squared plus 3t minus 1 to the second power. Now I could have went ahead and distributed that negative through, but I'll leave it as it is. Number 26, we're just getting in the habit of rewriting everything. So we're going to say that we have 1/2 x squared. This time I have 16 minus x squared to the 1/2 power. Hopefully you've recognized that you have two x's being multiplied together, so we have to use product rule and chain rule at the same time. This is the first time we've seen this. So the derivative would end up being, first, you're going to hear me talking about the product rule. So first, there's the first part, times the derivative of the second. Now here's where the chain rule takes place because I have this big x. The 16 minus x squared is standing for a big X. I'm going to bring the 1/2 out front. I'm going to rewrite it, lower it by 1, and take the derivative of what's inside. So the derivative of the 16 minus x squared, that's a 0, and then I have a negative 2x. So there's a lot going on in that, taking the derivative of the second part. I'm going to continue on with my product rule. So I was first times the second. Now I'm going plus second times the derivative of the first. So the derivative of the first is just going to be 2 times 1/2, which is 1. And then I'll end up with x to the first power. You will see this simplified. How do we simplify this? Well, we're going to have to work through this slower. So there probably will be another video here. We're going to have 1/2 times 1/2 times negative 2x with this x squared. So let's go ahead and put those three parts together. That ends up being 1/4 times a negative 2, which would be a negative 1/2, x to the third power. This would go on the bottom, so this negative 1/2 power would go on the bottom of the fraction. And then I would add on this x square root of 16 minus x squared. Now I could see them making a common denominator and then adding those together, but I am not going to go ahead and do that at this time. This last example is a longer example because I have a quotient rule written to the third power. So I have quotient rule and chain rule that I'm going to have to apply to this problem. The derivative of g of x is going to be, I'm going to pretend that this is my big huge x. So I'm going to take the derivative of just that part, which would be bringing this 3 out front, rewriting these huge parentheses with the squared part. Had this been just an x, I would have been finished, but it's not. I have to take the derivative of what's inside of here. Well, what's inside of there is a quotient rule. I am going to have to use quotient rule, and I'm going to multiply these together. So I will say my quotient rule statement, and I'll go ahead and make these different colors so that you can see where I'm talking about. I'm going to say bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. Now, if I leave it like this, it's right, and it would work out fine for me to just plug in a number at this point if they ask me to find the derivative at 2. But we're going to try to clean this up just a little bit, just so it looks just a little bit nicer. I am going to go ahead and just leave this first part as it was. So I'm just recopying it. Really, the only place I'm going to clean this up is back here. on this second fraction. I'm going to go ahead and distribute this part through, which gives me a 12x squared plus 18x. And then back here I have a minus, okay, and we'll distribute this 2 through. I have a minus 6x squared minus 4, and I said minus 6x squared, but that would be after I distribute that negative through, all over 2x plus 3 squared. So I guess I will take this just one step further. I will go ahead and distribute my negative through and combine my like terms. So I'll have 12x squared minus 6x squared, which is 6x squared, plus 18x, and that would be plus 4, all over this 2x plus 3 squared. The only thing else I can really do is bring down this other part. I'm not going to multiply these all together or anything like that. We'll just go ahead and leave our answer as this.